is more than 25 centimeters, focusing is not proper. Astigmatism, where light bends at the edges of the eye and therefore cannot be properly focused to the retina, and that can be rectified by using a cylindrical lens. Both these regions, there is modification in the distribution of light energy. Hello students, thought for the day: it does not matter how slow you go, provided you don't stop moving towards your destiny. Set up your destiny, set up your goal, progress towards it, achieve your success. In my today's class, we will have a skeletal view with respect to optical instruments, and thereafter we will expose and explore ourselves to wave optics, where we introduce a very beautiful phenomenon called interference of light. Now, in my previous session, I was talking about the most natural optical instrument, what I call as the eyes, accommodation power. We spoke about what actually eyes is and so on. Continuing my discussion, today we study something called least distance of distinct vision. Least distance of distinct vision. The word distinct means clear, or the word distinct means unique. Therefore, it is also called least distance of clear vision. We say clear and distinct. It is the closest distance of an object. By definition, it is the closest distance of an object. The eye lens can focus the light on the retina. See, proper vision happens when a ray of light falls on the eyes and it is focused to the retina of the eyes. The retina is called as the compactor of the eyes. All light that is incident on the eyes, only when channelized properly, only when sent properly to the retina, focused on the retina, then we say that vision is clear and distinct. So the smallest distance between the eyes and the object, where the light can be clearly focused on the retina, is called least distance of distinct vision. It is also called the near point. This least distance of distinct vision we also call the near point, and for normal eye it is 25 centimeters. Andre, if the distance between the object and the eyes is more than 25 centimeters, focusing is not proper. That is where we get cases of myopia, hypermetropia, what you call long-sightedness or short-sightedness. Therefore, for normal eye, proper focusing takes place for a distance of 25 centimeter, and this is called least distance of distinct vision. Myopia, one of the common disabilities of eye. Even kids today are replaced with spectacles, proper lens to overcome myopia or hypermetropia. Myopia is also called short-sightedness. The defect of myopia is called short-sightedness, and concave lens is used to rectify this defect. Hypermetropia, this is called long-sightedness, and convex lens is used to rectify this defect. So myopia, short-sightedness, hypermetropia, long-sightedness, convex lens is used to rectify this defect. And finally, we also have something called astigmatism, where light bends at the edges of the eye and therefore cannot be properly focused to the retina, and that can be rectified by using a cylindrical lens. These are all very meek concepts. Yes, seldomly asked in the exam. Next, a few thought ponders. This hot points rigorously asked for 1 mark in the exam. Magnifying power of either a simple microscope, compound microscope, or a telescope. Parikshanally, you will be asked to write the expression for the magnifying power of either a simple microscope, compound microscope, or a telescope. Now, for a simple microscope, the magnifying power is given by the expression M equals 1 plus D divided by F. 1 plus D divided by F, where F is the focal length of the convex lens which is used in the microscope, and D, least distance of distinct vision, what we studied, the near point. So the magnifying power of a simple microscope is given by M equals 1 plus D divided by F, where F is the focal length of the convex lens, D, least distance of distinct vision. Magnifying power of a compound microscope, M equals 1 plus D divided by Fe. So this is M equals 1 plus D divided by Fe, where Fe is the focal length of the eyepiece, and this is also equal to M naught. M naught, magnification due to the objective of the microscope, the least distance of distinct vision, and magnifying power of a telescope is F naught divided by Fe, focal length of the objective, Fe, focal length of the eyepiece. So the first is the magnifying power of a simple microscope. Second, magnifying power of a compound microscope. Third, magnifying power of a telescope. Now, we jump to a very, very beautiful phenomenon called interference of light, and it is here where we start discussing something called as wave optics. My dear students, right at the beginning of this chapter, we told geometrical optics and wave optics are generally the two branches of optics. And when it comes to wave optics, it is a branch where we study the different properties of light, considering that light is a wave. Here we are attributing or we are giving wave nature to light. We understand that light is a wave, and then we discuss the different properties of light. And we told it is a branch where we discuss phenomena like interference of light, diffraction of light, polarization of light, and so on. And thereby, in today's class, we will try to understand what is wave optics and hence the phenomenon of interference. ಬಹಳಷ್ಟು ಸರಿ ಹೇಳಿರ್ತೀವಲ್ವಾ, ಪ್ಲೀಸ್ ಡೋಂಟ್ ಇಂಟರ್ಫಿಯರ್ ಇನ್ ಮೈ ಬಿಸ್ನೆಸ್. ನನ್ನ ಕೆಲಸದಲ್ಲಿ ಮೂಗು ತೂರಿಸ್ಬೇಡಿ. The word Interfere means superpose, come in between, admixture ಅಂತ ಅರ್ಥ. Interference means superpose, ಮೂಗ್ ತೂರಿಸ್ಕೊಂಡು ಹೋಗೋದು. Come in between, admixture. Now it is interference of light. What is this interference of light? This can be clearly understood using the principle of superposition, which was given by the scientist Thomas Young. Please recall your waves that you studied in your 11th standard. Principle of superposition. What did it say? We consider two waves traveling in a medium. There are two waves that is traveling in a given medium. They have the same wavelength, same frequency, and constant phase difference. ಆ ಎರಡು ವೇವ್ಗಳದ್ದು ವೇವ್ಲೆಂತ್ ಒಂದೇ ಆಗಿರುತ್ತೆ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಸಮನಾಗಿ ಇರುತ್ತೆ, ಮತ್ತು ಅವುಗಳ ಮಧ್ಯೆ ಝೀರೋ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಅಥವಾ ಕಾನ್ಸ್ಟೆಂಟ್ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಇರುತ್ತೆ. Now I say y1 is the displacement of the first wave and y2 is the displacement of the second wave. So what happens here? These two waves superpose each other. These two waves interfere each other, and this is the resultant wave. And the principle of superposition says the displacement of the resultant wave, whatever wave is formed after superposition, whatever I call as the resultant wave, the displacement of the resultant wave is the vector sum of the displacement of the two individual waves. And this forms the principle to understand interference of light. ಅರ್ಥ ಆಯ್ತಾ? So please note, two waves travel in the same medium, they have same wavelength, same frequency, constant phase difference. They superpose now, interfere, gives rise to a resultant wave. A new wave is formed whose resultant displacement is y1 plus y2, vector sum of the displacement of the two individual waves. And this forms the principle. Young's superposition principle helps us to explain the phenomenon of interference of light. Dear students, the question is, why superposition of light does not happen when I use a single source? Why interference of light is not possible when I have only one source giving light? ಒಂದೇ ಒಂದು ಬೆಳಕಿನ ಸೋರ್ಸ್ ಉಪಯೋಗಿಸಿದ್ರೆ why interference is not possible? Please know this. With a single source of light, energy distribution in the surrounding medium is uniform. Whenever you use a single source of light, distribution of energy in the surrounding medium becomes uniform. There is uniform distribution of light energy in the surrounding medium. Therefore, no possibility for the light waves to interfere. No possibility for interference to happen. Therefore, I require two sources. Always, please do remember, for superposition of light waves to happen, I require two sources. Two sources are required which emit light wave of same wavelength, amplitude, frequency, and zero phase difference. These are the criterions for superposition to happen. Same wavelength, amplitude, same frequency, constant or zero phase difference. Under this condition, we see there are superposition of waves. Now, if the crest of one wave falls on the crest of other, or trough of one wave falls on the trough of another. Gamna it keli. If the crest of one wave falls on the crest of another, or trough of one wave falls on the trough of another, at the point where they interfere, intensity of light increases. When crest of one wave falls on the crest of the other, or trough of one wave falls on the trough of the other. If the crest of one wave falls on the trough of another, at the point where they interfere, intensity decreases. Which means at these points, there is redistribution of energy. And this redistribution of energy is called interference of light. Andre, ಒಂದು ಲೈಟ್ ವೇವಿನ ಕ್ರೆಸ್ಟ್ ಇನ್ನೊಂದು ಕ್ರೆಸ್ಟ್ ಮೇಲೆ ಬಿದ್ರೆ, ಅಥವಾ ಒಂದು ಟ್ರಫ್ ಇನ್ನೊಂದು ಟ್ರಫ್ ಮೇಲೆ ಬಿದ್ರೆ, ಎಲ್ಲಿ ಇಂಟರ್ಫಿಯರ್ ಆಗ್ತವೆ ಆ ಎರಡು ಲೈಟ್ ವೇವ್ಗಳು, ಅಲ್ಲಿ ಬೆಳಕಿನ ಇಂಟೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಆಗಿರುತ್ತೆ. ಹೊರತಾಗಿ ಒಂದು ಕ್ರಸ್ಟ್ ಇನ್ನೊಂದು ಟ್ರಫ್ ಮೇಲೆ ಬಿದ್ದರೆ ಬೆಳಕಿನ ಇಂಟೆನ್ಸಿಟಿ ಕಮ್ಮಿ ಆಗತ್ತೆ. ಅಂದ್ರೆ ಬೋತ್ ದೀಸ್ ರೀಜನ್ಸ್ there is modification in the distribution of light energy, and this modification in the distribution of light energy due to the superposition of two light waves is called interference of light. Simple, students. When there is superposition of two light waves, either intensity may decrease or intensity may increase. There is distribution or change in the light energy. There is modification in the light energy. That modification is called interference of light. And I told two sources are always required for interference to happen, and those two sources are called coherent sources. A very important one marker. Two sources which emit light waves continuously of same frequency, same wavelength, and constant phase difference. There are two sources of light. They emit light of same frequency, same wavelength, with constant phase difference. And such sources are called coherent sources. And these are the notes which we have just now understood. So please to remember, the modification or distribution of light energy when two light waves superpose each other, when two light waves cross each other, is called interference of light. If the crest of one wave falls on the other, or trough of one wave falls on the other, the intensity is maximum. If the crest of one wave falls on the trough of another, intensity decreases, and the pattern consisting of bright and dark fringes is called interference fringes. In my next session, I will come back with the theory of interference. Until then, have a glance on this session. Thank you.